All right, let's dive right into this explainer. If you work in tech, or even if you just rely on it, you've probably noticed that the ground beneath our feet is completely shifting. We used to protect physical boxes in locked rooms. Today, our infrastructure is literally made of code scattered all across the globe. So, how do we secure something we can't even touch? That's exactly what we're going to figure out today.
Here's our roadmap for today. We'll be hitting the cloud security matrix, navigating hybrid clouds, infrastructure as code, the serverless illusion, and finally wrapping up with microservices and zero trust. Let's start with part one, the cloud security matrix, and this really important idea of shared responsibility. Okay, so cloud computing is basically just on-demand capabilities over a network, right? Storage, infrastructure, whatever you need. It's scalable, it's cheap, but there is a major catch. You're handing over a ton of administrative control. This shared responsibility matrix brilliantly maps out who actually does what. Look at the bottom row, the physical infrastructure. Whether you're using infrastructure, platform, or software as a service, your cloud service provider, the CSP, always handles the concrete, the power, and the server racks. It's kind of like renting an apartment. The landlord fixes the roof. But that top row, across the board, you're always on the hook for your data and user access. The middle layer, things like the OS and apps, well, that's where the line shifts depending on the specific service you're using.
So the absolutely crucial takeaway here, you cannot make assumptions about security, compliance, or data integrity without explicitly checking your provider agreement. A lot of folks assume that because their data's in the cloud, it's automatically backed up or safe from insider threats at their own company. No way, it doesn't work like that. You could have the best encryption on the planet, but if you don't realize you're the one supposed to manage the access keys, you've essentially left the front door wide open. Moving right along to part two, navigating hybrid clouds.
Look, as organizations scale, they rarely stick to just one environment. They mix private and public cloud services to share data and applications, creating a hybrid architecture. And when it's done right, it really gives you the best of both worlds. You get the strict, rigid control of a private cloud for your highly sensitive, regulated data, right alongside the sheer efficiency and massive scalability of a public cloud for your customer-facing web apps.
But, and it's a big but, mixing these environments is a serious balancing act. You've got to figure out seamless data synchronization. You need incredibly robust network connections because a slow, high-latency connection between your public app and private database will completely ruin the user experience. Plus, you have to unify security protocols across totally different domains, align with different privacy laws, and somehow manage the headache of combined public and private costs. Now, to solve some of those headaches, we often bring in third-party vendors for specialized analytics or security tools. While that does boost functionality, it dramatically increases your exposure. Think about it. You secured your own house, but what happens when you give a third-party vendor a copy of the keys? You're bringing an external organization right into your environment, introducing outside vulnerabilities that you cannot easily manage or patch yourself.
Which brings us to part three, infrastructure as code, and abstracting the network.
Modern deployments are just incredibly complex now. We're integrating so many systems and APIs that humans physically configuring routers and servers, it just can't keep up with business needs. Enter software-defined networking, or SDN. SDN fundamentally flips the script by decoupling the control plane from the data forwarding functions. So instead of manually logging into dozens of physical switches, we can just centrally manage and program virtual networking appliances in an instant. And that central management scales all the way up into infrastructure as code, or IAC. Now, whole data centers are provisioned not by turning screws or plugging in cables, but by executing machine-readable definition files. You write a script, hit enter, and boom, 100 servers, load balancers, and firewalls spin up in seconds. It's amazing. But ironically, this introduces massive new risks. Just one tiny network configuration error in your code can instantly deploy across your entire environment, causing huge downtime and gaping security holes before you even realize what hit you. All right, part four, the serverless illusion. So, if we're coding our infrastructure, we arrive at the ultimate abstraction, right? Serverless. But if it's serverless, where are the servers? Make no mistake, there is absolutely a massive physical server sitting in a data center somewhere. You just aren't the one provisioning it, updating the OS, or maintaining the hardware. Instead, the cloud provider, like AWS Lambda for instance, dynamically manages all that server allocation for you. Your code runs in these stateless, ephemeral containers. Ephemeral just meaning they exist for a split second. They're event-triggered. A user clicks a button,
The provider instantly spins up a container, runs the code, and shuts it right back down. It gives you incredible high availability, and the best part is, you literally only pay for the exact compute time you use. If you look at this timeline, you can literally see our physical control disappearing over the years. Decades ago, we had physical servers. Then we moved to virtual machines, abstracting the hardware. Then containers came along, abstracting the OS. And today, serverless solutions abstract everything except the code itself. We're stepping further and further away from the hardware with every single era.
And finally, part 5, microservices and the zero-trust model.
So what's actually running on all these highly abstracted architectures? Microservices. Back in the day, we built monolithic applications, just one giant tangled block of code. Today, microservices break that down into highly testable, independent pieces organized around specific business capabilities. Like an e-commerce site will have one microservice just for the shopping cart, a totally separate one for authentication, and another for inventory. And these container-based services talk to each other and third parties entirely through APIs.
But here's the catch, and it's a huge one. Because these environments are virtual, constantly shifting and spinning up and down in milliseconds, your traditional network security strategies, they are completely useless here. You can't just slap a traditional firewall at the edge of your network and call it a day, because that traditional perimeter simply doesn't exist anymore.
To actually secure these APIs and microservices, you need microsegmentation. This means enforcing your network segmentation at the virtual machine level or directly between containers within a subnet. Your security basically has to become application-aware. The policies must start and end with the application itself, rather than relying on the physical network layer.
Which naturally mandates a zero-trust model. Zero trust is exactly what it sounds like. Absolutely no communication is trusted by default. Under this framework, a user can't talk to an application, and more importantly, one app cannot talk to another app unless a rigidly defined set of policies explicitly permits it. Even if they're on the exact same virtual network, trust is never, ever assumed. That's how you maintain tight control even when your infrastructure is entirely invisible to you. As we wrap up this explainer, I want you to really think about this. As your hardware completely disappears into lines of code, ephemeral containers, and third-party services, who is truly in control of your security? When you no longer own the server, the cables, or the operating system, how are you going to redesign your security to protect your data, the one thing that still actually matters? The answer lies in mastering the shared responsibility model, embracing microsegmentation, and never, ever trusting anything by default. Thanks for joining me on this deep dive. Catch you next time.